So good day everyone, my name is Jason Masin and today I'll be presenting our study on machine learning approaches for banana quality classification. This performance comparison of G48 and random forest algorithm. But before I begin, I would like to, uh, on behalf of my co-authors, I would like to introduce my co-authors, Dr. Roderick Malanza and Ms. Jennifer Random. And we are all from Starlity State University, Philippines. Sorry, sorry. Uh,
Go ahead. Share the screen.
Hello again. Is it visible already?
Okay. Go ahead.
Okay. So again, my name is Jason Masin, and I'm here to present a study about machine learning approaches for banana quality classification, a performance comparison of G48 and random forest algorithms. So I would like to thank also, I would like to take this opportunity also to thank the International Conference on Dependable System Services and Technologies for accepting this study. So to um, so here's the overview of for my presentation. We will begin with the introduction of the study, followed by the problem statement, objectives, and the methodology used. Then we'll discuss the results and comparison of G48 um, and random forest algorithms. And finally, conclude with findings and recommendations. So introduction, so bananas are one of the most widely consumed foods globally, and uh, they are a potential source of income and employment in typical economies like here in the Philippines. Maintaining high banana quality is essential for market competitiveness, and ensuring the quality is uh, the key to meeting consumer satisfaction and avoiding economic loss or losses. So for the problem statement, traditional assessment of um, banana quality is rely on human visual inspection. Uh, these methods are selective and inconsistent and prone to errors. Visual inspection are time-consuming and inefficient, so the inefficiencies lead to consistent quality assessment and potential financial losses in the supply chain. So the objective of the study first is to evaluate the effectiveness of these two algorithms, which is the G48 and the forest, in classifying the banana quality. Um, Next is to compare the performance of these algorithms based on accuracy, precision, recall, and cost benefit. And also, lastly, is to determine which algorithm is better suited for the reliability and efficiency of the banana quality assessment. So here in our methodology, um, this is the conceptual framework of the study. Um, these slides illustrate the conceptual framework for study. We begin with the data processing in Weka, and uh, it is split into training set and after an testing set. And then the training set is used to train two machine learning algorithms or models, which is the GPT neural forest within Weka. And after the training, the models are tested on testing set to evaluate their performance. And finally, we train the models predict or classify the banana quality based on the various metrics such as accuracy, precision, so For the data collection, we collected our data set from Google.com, which has seven certificates in one class. For the class is along with the quality good or bad. And for the data processing, first we convert the file into bigger format, which is the R file. So, so the database is compatible with our tools that we create. Next is normalization to standardize the attribute scales. Next is the feature selection to focus on the models on the most relevant data. So after that is the data splitting. So we split our data into two. So one for training. So 66% is for training and 34% for testing. So this tips ensures that the data set was ready for accurate model training and evaluation. So the results and discussion. So these are the result for the G48. So the slide shows the performance of G48 in classifying banana quality. So the model took 0.09 seconds to build the model and zero 0.01 seconds to test the phase split, and it correctly classified 87.9902% instances with 12.01 incorrect instances. Um, and also the model ROC area is 0.85, indicating good performance but room for improvement as in the false positive rate of 0.1. So this slide presents the cost and the benefit analysis for G48 algorithm. So when classifying the banana quality, so on the left side, you can see the analysis for good quality bananas, and on the right we have the analysis for bad quality bananas. The curve represents the relationship between the classification um, threshold and the propensity rate, showing how varying the threshold impacts model performance. So for good bananas, G particular for accuracy of 87.7%, and the cost of calculation increase as the threshold changes. So for the bad bananas, G shows slightly higher misclassification cost if the model struggles a bit in identifying lower quality bananas. Um, so for the result of the random forest algorithm, the slide presents the performance of random forest algorithm classifying banana quality. So the model took 0.34 seconds to build and 0.1 second to test the similar. It is similar with G48. So random forest correctly classified 90.2% of instances with slightly lower miscalculation rate than G48. So it achieved a high ROC area of 0.0 uh, 960, indicating with better overall performance and accuracy in distinguishing between good and bad quality bananas. So for the for this slide shows the cost benefit analysis for the undercourse algorithm. So again, on the left side, you can see the performance of good quality bananas, and on the right side, it's for the for the bad bananas quality, or for the bad quality bananas. So the plot shows the relationship between the classification threshold and the true positive rate, demonstrating how changing the threshold impacts the cost and benefit for each classification. So for good bananas, random forest shows high accuracy. Its cost benefit curves indicates minimal miscalculation cost. Um, for this slide, this table compares the performance of G48 and random forest across the three metrics, so the precision, recall, and the cost benefit. So for good quality bananas, random forest achieve slightly higher precision of 0.853 and a recall of 0.926 compared to G48. With a cost benefit score of 47, so it is indicating fewer miscalculation cost than the J48. So for the bad quality bananas, random forest also outperformed the J48 with high precision of 0.923 and a better cost benefit score of 37 compared to the G48 score of 49. So overall, random forest outperformed G48 in both accuracy um, and ROC area and sorry, making it better model for banana quality classification. So for the conclusion, the study found that random forest consistently outperforms G48 in terms of accuracy, precision, and recall for banana quality classification. So random forest proved to be more effective in minimizing miscalculation and provide better benefit result overall. And based on these findings, random forest is recommended as preferred model for efficient and accurate banana quality assessment. Also, for the recommendation, we will adapt the random forest for banana quality classification due to its high accuracy and better cost benefit performance compared to G48. So, and also we will integrate random forest with real-time data systems to further enhance the efficiency and accuracy of the quality assessment in the agriculture area or sector. And that would be all for my presentation. Thank you.
Thank you, Jason. Thank you very much. Any questions?
I have one question. Could you use your model for analyzing of quality other types of fruits?
Pardon, sir.
Sorry,
Can you please
you need
repeat
repeat
the
my question or not?
Yes, repeat it,
Okay.
please.
Could you use your model for analyzing of quality other types of fruits?
Yes, we can use this model in different fruits. Yes, sir. We can use this model, not just banana, but other fruits. We can use this model for identifying quality.
Okay, for example, if you change initial data for figs, for example, you can use your model for analyzing or forecasting some information about other fruits or not.
Pardon me, sir. Can you please?
Okay, if you change initial data, uh, could you use your model for forecasting or analyzing other type of fruits?
I think we can use this model also, sir.
If you okay, if you change input data, yeah, if you use new data for your model, could you use your model for analyzing other type of fruits?
Answer. Thank you. Your
Can
question
you
is
repeat?
referring about if I use another data, do I need to use this model? Is it right, sir?
Yeah,
About that.
my question, could you use your model, yeah, which has presented on the from report, used for analyzing other type of fruits, for example, figs or apples, for something else?
No, sir. This study focus also focusing for the quality of the banana, or we can use this model for identifying other fruits. Like if we want we want to identify the quality of the fruits, we can use that. But for that said, I'm not going to use this model. It's not applicable for that.
Thank you. Thank you for your answer.
Thank you very much.
Other questions, please? Okay, thank you very much, Gerson. Thank you.